Hello students, here we have problem number 23. A person stands on a scale in an elevator. As the elevator starts, the scale has a constant reading of 591 newtons. As the elevator later stops, the scale reading is 391 newton. Assuming the magnitude of acceleration is the same during the starting and stopping, determine the weight of the person's mass, and acceleration of the elevator. Now, let me draw it. So basically, when you are inside the elevator, and here we have a scale, okay? We have a scale, and someone is standing on the scale. Now, when it starts, so basically when the elevator starts, the scale has a constant reading of 591 newtons, right? But later on, when it stops, the scale reading is 391. So let me write it down. So 591 when elevator starts, and 391 newtons when it stops, right? So we all know that all elevators are moving with a constant speed. Why? Because so that we don't feel the force on us. Now, but however, when elevator started, say initial velocity was 0, right? But however, before reaching a constant speed, let's say it's equal to, I don't know, 5 meters per second, there is an acceleration, okay? There is an acceleration. So we know that acceleration is equal delta V over delta T. Now, when elevator starts, which means we're going to have the upward normal force exerted by the floor on the passenger, okay? So here, when elevator is moving upwards with an acceleration, then this floor is going to exert a force on the scale, okay? Now, say this one is a normal force. Now, then we have the weight of the person, which is mg, okay? As I said, when elevator is moving upwards or starts the moving, then we can say that normal force minus mg, and it is equal to ma. This one actually gives us some of the forces in y direction, okay? And since elevator is moving, then we have acceleration. Now, in this case, what we have, when it started, so we have 591 minus mg, which is equal to ma, okay? But however, suppose you are going from floor 0 up to the 5th floor, okay? Floor 5th. So what happens when you just trying to reach 5th floor, the direction of acceleration is actually changing. Why? Because it's decelerating and it wants to stop, okay? So in that case, your acceleration will be pointing downwards, okay, when it wants to stop. So in that case, what we have, so we know that in the second case, acceleration will be downwards when it's going to stop. So suppose you moved it from first floor, or from 0 floor to the 5th floor, then acceleration is upwards. But when it's going to stop, then acceleration will be pointing downwards, so that they want to decelerate the elevator and they want to stop the elevator, okay? So in that case, we have 391, normal force stays the same, minus mg, which will also stay the same, but however, in this case, is negative ma. Why? Because acceleration, when it's going to stop, will be pointing downwards, okay? So first of all, we have to find acceleration. So in order to find that, okay, so in the first case, we have to find what? We have to find the weight of the person, right? If you want to find the weight of the person, then in this case, we want to get rid of the acceleration, so we can just sum these equations, okay? Equation 1, this is equation 2. We're going to sum them. Once we sum them, what we will get? We will get 591 plus 391 will give us 982 minus 2mg, which is equal to 0, right? So because this will cancel out when you add them. Then you can say that your mg is equal 982 divided by 2 will give you 491. Okay, so that means the weight of the person will be 491. Okay, or if you measure your weight while you are stationary, then your weight will give you 491. So in a part B, we have to find what? We have to find the person's mass. So person's mass is basically the weight is equal mg, and the person's mass will be the weight divided by the g. So 491 divided by 9.8 gives you 50 kilograms. So the mass of the person is 50 kilogram. Okay, now in the last moment we want to find acceleration. Okay, now in order to find acceleration, you can use either first formula or second form, or first equation or second equation. It doesn't matter, you will get the same acceleration. Or suppose we have, okay, the weight, we found the mass. So let's use just the formula which we got it. Let's use the first one. So first one is 591 minus mg, which is equal to ma, right? So you want to find acceleration. Acceleration is equal 591 minus mg divided by the mass. So 591 minus mass of the person was 50 kilogram, multiplied g is 9.8, divided by the 50 kilogram. So if you do calculation, you should find that your acceleration is equal to 2 meters per second squared. Okay, this is how you can find acceleration.